In this video, we're going to be looking at dividing fractions and mixed numbers. Real simple rule. When dividing fractions, you must actually multiply by the reciprocal. And the reciprocal, as our definition shows here, is to flip a fraction so that the numerator becomes a denominator and the denominator becomes a numerator, which is a big long way to just simply zero in on this keyword, flip. That's all you're going to do. You might hear the phrase come up, keep, change, flip, which means keep the first fraction the same, change from division to multiplication, and then flip the second one, which is a kind of a low-key way of saying multiply by the reciprocal. Here's an example. 3/8, the reciprocal is 8/3. All we did was flip it. And then finally, mixed numbers, which we're going to get to in a little bit. That's the one where you have a number in front of the fraction, like 1 3/4. The big idea there is that you're not able to really work with a mixed fraction. You're going to have to turn it into an improper fraction before doing any type of operation with it. So let's get started. Find the quotient of 15 and negative 2/3. Now the first thing we need to be aware of is that 15 itself is a fraction. It's a rational number. This is 15 over 1. And that's going to be important in just a moment. So we're going to rewrite the problem as multiplication. We keep the first one the same, 15 over 1. Change division into multiplication, and then flip the second one, or find the reciprocal, which is going to be negative 3/2. Okay? And as you remember from multiplication, we look to see if there's anything in common top to bottom. 2 and 15 don't have anything in common. We have a negative times a positive, so our final answer is negative. 15 times 3 is 45. And 2 times 1 is 2. And to be honest, you can leave the answer just like that. It's negative 45 halves. Now this one does involve a mixed fraction. So before we do anything else, we need to change that mixed fraction into something we can work with, an improper fraction. And as you remember, what you do is you multiply the denominator by the integer in front of the fraction and then add the result to the numerator of the fraction. 5 times 1 is 5. 5 plus 3 is 8. We're dealing really with the improper fraction of 8/5, which is being divided by negative 1/2. And I realize we could have gone ahead and done our keep, change, flip, or multiply by the reciprocal already, but I just didn't want to skip that step for you. Now we'll rewrite the problem. 8/5 times the reciprocal, which is negative 2 over 1. Anything in common top to bottom? No. We again have a negative times a positive, so the answer is negative. And we're going to get 16/5. Personally, I'd like to leave the answer that way. But you know what? Since we started with a mixed fraction, and it's good to practice this skill, why don't we go ahead and turn it into a mixed fraction? This is going to be a negative number still. And 5 goes into 16 3 times. 3 times 5 is 15. And 15 is 1 less than 16. So we have negative 3 1/5. Either one of those is a correct answer. It's going to be up to the context of the problem or your own instructor or what's really being asked for to determine which one you might have to do if there is a requirement. All right. Well, this time we have two mixed fractions. We're going to need to change both of them. Let's ignore the negatives. We know the first number is negative. 4 times 2 is 8, plus 3 is 11. So it's negative 11 fourths. Divided by, still a negative number, 1 times 3 is 3, plus 2 is 5. So we have 5/3. Now we can do the new part, which is to keep the first fraction the same, change division to multiplication, and multiply by the reciprocal. There's nothing in common, anything on the top to the bottom. We have a negative times a negative, same signs. It's going to be a positive answer. 11 times 3 is 33. 4 times 5 is 20. Let's go ahead and leave the answer that way. 33 over 20. Well, mixed fractions really only are going to truly show up in a word problem. You're not going to say something like 7/2 pounds of ground beef if you're going to the local supermarket to buy. You're going to get 3.5 pounds. So that's where the real world scenario comes in. But let's go ahead and change this to an algebraic expression, and then we'll find the answer here. Stephen has 3.5 pounds of ground beef and wants to make burgers. How many quarter-pound burgers can he make from his 3.5 pounds of ground beef? So what we're looking to do is to take 3.5 pounds and divide that into however many equal quarter-pound pieces we can create. Step 1, get rid of that mixed fraction. 3 times 2 is 6, plus 1 is 7. So we do have 7/2 pounds of ground beef. Try that the next time you go to the supermarket and ask for 7/2 pounds of ground beef. See how they like you working. And now we'll keep change flip. 7/2 times 4 over 1. And finally, we actually do have something extra we can do. There is something in common between the top and the bottom, because the number 2 goes into 4 2 times. We end up with 7 times 2, which is 14, over 1. The 1 is really unnecessary, so we can just say 14. And this is a word problem, so 14 what? 14 burgers. I can't eat that many. Maybe he's having a party. Well, that's how we divide fractions and how to deal with them when there are mixed numbers involved as well.